Let's do an example B for number 3. And I have another work problem here. So now we have 2 Chef Boyardees, and they're preparing for a banquet. And one chef can prepare the banquet in 2 hours less time than the other. We got little apprentice, some master guy. And today they complete the job, and together they can complete the job in 5 hours. How long to the nearest tenth would it take the faster chef to work alone? How long will it take the faster chef to work alone? All right, so first thing in any word problem is let's let x equal some variable, something that we don't know. Okay, so we're going to let x equal. Now, in this case, it tells us in the problem here that they want us to find how long is it going to take the faster chef to work alone. However, I'm going to let x equal the slower chef. Now, it's not that it's incorrect. It's just a very common practice that when we do these problems, the work problems, let's let x equal the slower chef. We could let x equal the faster chef as well. It just kind of means that when we look at the problem of the information given to us, we kind of have to think about it backwards. And I'll show you the backwards thing in a minute, but let's just let x equal the slower chef. And hopefully this will make sense here. So, how long will it take the slower chef to do it by themselves? Again, so we're going to say 1 over x, just like we did in the first problem, in the first example. And how long will it take the second chef? Well, it says that one chef can prepare the banquet in 2 hours less. So if someone does it 5, then I subtract 2 from this. Or if someone does it in 10, then I subtract 2. So I'm going to do x minus 2, because the faster one can do it in 2 hours less. Okay? And again, we do 1 over because it's in 1 hour. In 1 hour, they do this amount of work. In 1 hour, they do this amount of work right here. Okay? Now, if we did let x equal the faster chef, you would have let x equal here, but then you would have had to have thought about it. Okay, well, that means then that if that's x, then this has to be x plus 2. And you just have to kind of think about it because it says less. I mean, usually that means minus. So that means you would have had to done it backwards. We would get the same answer at the end, but we're just going to do it with the less than. Okay. All right. So that's the first column. Let's go to the second column right here. How long does it take them to do it together? 5 hours and 5 hours, right? If they give that to us right here, they work in 5 hours together. So that's always going to be the same number. And the way that you get the fractional part is you multiply these. Okay. 1 over x times 5 is 5 over x. Just multiply 5 and the 1, and then put the x on the bottom. And then here, multiply the 5 and the 1, so you get 5 over x minus 2. Okay, so this is how much work the job gets done in a fraction, or this is the fractional part that the job gets done. This is the fractional part that the job gets done. So if I add both the slow dude and the fast dude together, that's all going to equal 1 job. Okay? So hopefully you see the similarity of the same thing we did from last problem. Take this guy, 5 over x, plus the second dude, 5 over x minus 2, and that equals 1 job. A fraction of 1 job plus a fraction of 1 job, those two will equal 1 job together. Okay? So now let's solve this. First find the lowest common denominator. And again, you just multiply the denominators together. So it's x times x minus 2. Cool beans. Now let's multiply everything by our lowest common denominator. All right. So we'll do x times x minus 2. And then we'll multiply this by, oh, I guess we don't want that right there. Let's see if we can fix that. See if we can fix that. There we go. 5 over x. And then plus okay. X times x minus 2 times that by 5 over x minus 2. Notice I'm multiplying every term by our LCD. Okay. 1 times this, so it's just going to be itself, right? X times x minus 2. Okay, and something always cancels. The denominator is always going to cancel, so we have x, and the x's cancel out. So now let's multiply 5 times x, and I get 5x. And 5 times -2, -10. Plus, negative, or x minus 2 cancel. So I just get 5 times x. So I get plus 5x equals, I'm going to go ahead and do the distributive property. So x squared minus 2x. And now we have a quadratic. Let's put it in standard form. Okay, I'm going to go ahead and add these guys together. So I get -10 plus 10x equals x squared minus 2x. Let's go ahead and move this 10 over here and move this 10x over here. So I'm going to subtract 10x from both sides. And then in the same line, I'm going to go ahead and add 10 to both sides. All right, doing all that, hi-ya, hi-ya. I get 0 equals x squared, -2x minus 10x is minus 12x plus 10. Cool. If this was factorable, that would be nice. However, it's not. We would use the factoring method. So since it's not factorable, we have to use quadro formula. Yeah. X equals -b plus or minus square root b squared minus 4ac all over 2a. All right, let's go ahead and plug in our values in. So we plug in our b value right here, which is -12. Plug in our b value here, -12. Plug in our a value here, 1. Plug in our c value here is 10. And plug in our a value here is 1. Let's keep rolling. Negative gives us a positive 12. Plus or minus the square root. -12 square root is 144. -4 times 1 is 4. Times 10, that's -40. A negative times a positive is negative. And a negative times a positive is a negative right there, all over 2. So x equals 12 plus or minus the square root of 104 all over 2. Okay. So since this is a word problem, a real life problem, we want to represent our answers as decimals. We don't want to leave them like this, because in the context of the problem, we don't say, oh, someone can do a banquet in 12 plus the square root of 104 over 2 hours. It's like, what the heck, dude? You must be in the NFL. You'd be like, heck yeah, I'm in the NFL. Well, we don't want to go that nerdy, so we actually want to use our calculator and represent these answers as decimals. Okay, so let's represent that as a decimal, and let's represent this as a decimal as well. All right, so just use the power of your calculator. This guy right here will give us 11.1, and this right here will give us 0.9. Okay, so let's look at this. Just by looking at the answers and in the context of the problem, one of the answers should not make sense at all. You're like, dude, this don't make sense at all. Okay, what does X represent? The slower dude, right? So if X is the slower dude, it's not possible for him to do the job by himself in 0.9 hours when it says that they do the job together in 5 hours. That doesn't make sense, because if he's doing it in 0.9 hours or in 50 minutes, then that means that the faster guy is going to do it faster, and it won't even come close to being 5 hours, right? So just by using some reasoning and some logic right now, you're like, all right, dude, that doesn't make sense. So we're going to go ahead and cross this out right here, and I'm going to use my cool rainbow. No, that one's gone. Okay, so we're not going to use that answer right there. All right, but this guy, yay. That's a kind of cool little thing right there. 11.1, again, represents the slower guy. So he does it in 11.1 hours. But let's look back at the problem. It says, how long would it take the faster chef to work alone? Well, if it takes, go back down there. If it takes the slower guy, if it takes the slower dude 11.1 hours, then the faster guy, if we read back in the problem, did it say he does it 2 hours less? So 9.1 hours. And that would be our answer right there, 9.1 hours.